We're hearing a lot about key skills in the new junior cycle reform. Can you provide us with some examples of how Catalyst supports the development of the junior cycle key skills?
During the production of Catalyst, every effort was made to align all materials in the package with the central features of teaching and learning outlined in the new junior cycle reform. And as such, we carefully considered all of the 24 statements of learning, in particular the 8 learning outcomes that are linked explicitly to science, and of course all of the 8 key skills, including each one of their individual elements. Key skills are crucial to the development of students, not just as scientists, but also as happy, engaged and productive young learners and members of society. Key skills are written in student-friendly language and they should be shared with students. Students should know that they're developing skills that will help them to develop and grow as people, learners and ultimately as scientists. We have produced an exclusive key skills poster for the classroom which locates the key skills within the subject of science and illustrates how they may be activated through engagement with all of the different types of activities in Catalyst. It's up to the teacher to decide on which key skills they plan to focus on for any given lesson or activity. In Catalyst, we've developed an exclusive key skills button in the teacher's ebook, which identifies potential examples of the types of key skills that can be engaged with and ultimately activated by students during the course of those activities. And as such, then we made a conscious effort to ensure that on every page of Catalyst, students were afforded the opportunity to activate at least one, if not many, of the different key skills. For instance, as a means of activating the element exploring options and alternatives of the key skill being creative, the science specs suggest that students should experience learning activities that engage them in scientific inquiry, where they generate and seek to answer their own questions, where they try out different approaches when working on a task and evaluate what works best. In order to allow students to be truly creative and to ultimately grow into the role of genuine investigators, in Catalyst, we have moved away from the traditional cookbook or recipe approach to experiments in science. We like to think that students are given genuine opportunities to be creative and pose their own hypotheses, investigate these hypotheses and evaluate the results and their learning throughout this process. The science investigations template in the Catalyst portfolio supports and scaffolds the students' progress through many genuine opportunities for scientific investigations. The opportunities for scientific investigation span the whole spectrum of the inquiry, ranging from limited, structured, guided to open, which over time and with help from the teacher, of course, will allow students to be more creative in the way they approach investigations and solve problems. The dedicated working as a scientist tasks at the end of each chapter provide students with further opportunities to be creative, to consider various alternatives as they develop their thinking and investigative skills around the work of scientists in specific areas. The move away from recipe-type experiments in Catalyst is perfectly timed as it eases the NCCA's concerns about such an approach in science textbooks, stifling any genuine change in Irish science education. As practicing teachers, we are aware that teachers will also require support, and the dedicated Teachers Resource Book offers guidance on suggested materials, methodologies, points to note, suggested extensions for all activities that are present in the textbook. And we believe that Catalyst is written in the right spirit and will be engaging for the student but also supportive for the teacher. As a means of activating the element using numbers and data of the key skill communicating, the science specs suggest that students should experience learning activities that will allow them to interpret, compare and present information and data using a variety of charts, diagrams that are fit for purpose and audience using relevant scientific terminology. So Catalyst promotes lots of different and innovative approaches for presenting information from science and society tasks and big challenges throughout the textbook. As an example, the big challenge at the end of chapter 9 encourages students to use modelling clay and a stop motion video to model how a change of state from a solid to a liquid to a gas may be explained using the particle theory. In the working as a scientist activity at the end of chapter 17, students are encouraged to write a blog about the physics of seatbelts. And of course, the teacher's ICT handbook is full of useful ideas about using digital resources to present information that may be shared with students. Catalyst provides many learning opportunities for students to engage with the other key skills as well, of course, namely being literate, being numerate, managing myself, staying well, managing information and thinking, and also working with others. The exclusive key skills button in the teacher's ebook will support and guide teachers as they select learning activities for students that will enable them to engage and activate the key skills of junior cycle. The exclusive key skills poster will also be a great support for students as it will enable them to become more familiar with the key skills of junior cycle and how they may be engaged with through the subject of science through the use of Catalyst.